Hi everyone. So this class we are continuing with the topic that is methods to overcome the intraocular barriers. One session we have covered the last week on the same topic. So the various methods for to overcome the intraocular barriers includes use of penetration enhancers, use of drug carrier system, and use of mucoadhesive polymers. Among the three methods, the last 1 week we have fully discussed on the use of penetration enhancers. Those who have not listened to the session, you can listen to the previous session, that is penetration enhancers, how does it act to increases the permeability of drug into the ocular through the ocular barriers. Now, today's session we are discussing on how the mucoadhesive polymers, or what are the role of the mucoadhesive polymers in overcoming the intraocular barriers, thereby increasing the permeation of the drug molecules. The bioaddition refers to the process of attachment of the drug and the carrier system into the biological membranes. So bioaddition or mucoaddition is may not be a new term for you, but this, even though we are discussing little bit into this topic. So the biological addition of this drug molecule or addition of substances into the biological membrane, we generally call it as bioaddition. So biological membrane, it can be the epithelial tissue or it can be any of the mucous membrane where it is having mucus secretions through the outer surface. Now, if the addition of any of this drug substance into a mucous membrane, a membrane that secretes the mucus, which is having a mucus layer in its outer surface. So such type of layers, the addition of the drug molecule or addition of the substances, any of the substances into this mucus layer, we generally call it as the mucoaddition. Now, as we know, if we consider our eye is having tear secretions. So eye is fully flourished with aqueous fluids. Now, administering the one of the main barrier what we learn is immediately after administering the drug can be diluted with our vitreous humor, it can be diluted with the tear flows. There it can be secreted out or it can be excreted out of the tears, or it can be go out of the cul-de-sac. So this is one of the main drawback we have observed. Now, how to overcome those drawbacks? By using the concept of mucoaddition. So, utilizing the principle of mucoaddition for the drug delivery will help to enhances the permeability. Now, in this concept, what happens? The drug what we are administering as a mucoadhesive, this mucoadhesive drug adhere to the mucus layer, thereby it increases the retention time. This is one of the main mechanism how a mucoadhesive ocular drug delivery systems enhances the permeation of the drug. So it increases the residence time. That means it resides in the ocular cavity for a longer period of time. Also, it provides an intimate contact between the drug as well as the corneal layers. If it is a normal solution or a normal tear substitute, whatever we are adding, it mixes up with the tears and it is being drained off. Whereas administering as a mucoadhesive delivery system, this may be viscous one. This may remains in the cul-de-sac for a longer period of time. That means it is not easily diluting with our tears. It is not draining out of the cul-de-sac. it provides a more chance for permeation of the drug into the corneal layers. Now, the mucin is one of the main part of the tear film. It forms the bottom tear film one layer, and it is adjacent to the corneal epithelium. The lowermost layer of the tear film, that is the mucin, which forms a bridge between the hydrophobic corneal epithelial cell surface and aqueous layer of the tear film. So the bridge is between, that is, as we know, the cornea is of hydrophobic in nature and the aqueous layer. So mucin act as a bridge between the hydrophobic corneal layers as well as aqueous tear films. This mucin, it consists of, or the composition varies from various species to species. It is having glycoprotein, which is capable of forming a highly vasoelectric gels, and it is having a major concentration of water, that is about more than 95%. Now, how this mucoadhesive system works? As we discussed earlier, it increases the intimate contact between the bioadhesive and the corneal membrane. It also functions by increasing the wetting of the bioadhesive surface, that is the mucin layer, or which helps in swelling of the bioadhesives. That means the bioadhesive substance what we are administering, it increases the retention time. Then the mucin layer as well as the tear films will helps in wetting up of the bioadhesive layer, and it also helps in swelling of the bioadhesive layer. Once it is swelled, the next stage is spreading of this bioadhesive layer. It has to spread over the entire corneal layers. So first step of this mechanism is increasing the contact and spreading. The second step is increasing the penetration of the bioadhesive into the tissue surface. So first step was increasing the retention and spreading. Spreading is done with the help after swelling. So retention, swelling followed by spreading. The next stage is penetration of this bioadhesive. Now at molecular level, if we consider the various attractive forces like van der Waals forces, electrostatic attraction, hydrogen bonding, hydrophobic interactions are the main mechanisms that increases the retention or mucoadhesion. That means by the van der Waals forces or electrostatic attraction or hydrogen or hydrophobic bondings, this polymeric substances can be adhered to the mucous membrane. So this mucoadhesion is done with the help of certain polymers. The polymer has its own specific characteristics. When the drug is being combined with this polymer, and it can be prepared as any colloidal or any of the suspension or viscous liquids, this colloidal form of the drug delivery system, once it administered into the eye, the polymeric substances that can control the dilution, that can control the delivery of the drug from this colloidal suspension into the corneal layers. Thus, in this type of mucoadhesive system, polymers are the sole part of the drug delivery system that plays the main important role to increases the retention time and to release the drug over the cornea for a longer period of time. So these polymers used are also the bioadhesives. They are the macromolecular hydrocolloids with various hydrophilic functional groups, and they can form the hydrogen bonds. And they are also high molecular weight molecules which cannot cross the biological membrane. That is one of the main speciality of this polymers. They are of highly molecular weight substances which is not easily permeating the biological membrane. The various polymers used includes, that is, hydroxypropyl cellulose or hydroxypropyl methyl cellulose, that comes under the category of non-ionic polymers. Then Chitosan and DEAA dextran as the polycationics, and polyanionics include polyacrylic acid derivatives, carbopols, carboxy methyl cellulose, etc. as the polyanionics. So these are some of the categories of polymers that are utilized for mucoadhesive drug delivery system. This bioadhesive power of a polymer is affected only by the nature of the polymer but also by the nature of the surrounding media. That means even though if you are administering the mucoadhesive polymer solution, the property of the solution is also affected by the tear film, because as the cul-de-sac is full of, there is always been filled with the tears. The tears can affect the property of the bioadhesive system, as well as the various polymer related factors which also contributes to the mucoadhesion, which includes the molecular weight of the polymer, the concentration of the polymer, flexibility, and the spatial conformation. So these are some of the polymer related factors. And the environment related factors includes the pH, swelling, and the initial contact time. Physiological variables includes the mucin turnover and the disease state, which can affect the formation of the tears, and the physiochemical properties of the polymer such as spreading as well as absorptive characteristics. So these characteristics of the polymers can affect the mucoadhesion. Now, apart from all this, the one of the main property of the polymer is the pseudoplastic behavior. Why the pseudoplastic behavior is necessary? That means if it is a pseudoplastic behavior which do not influences the viscosity characteristics of the precorneal tear film. That means if the polymer what we are selecting is having a pseudoplastic characteristics or pseudoplastic viscosity nature, the interaction between the tear film and the polymeric membrane will be less. That means the tear film may not, the viscosity of the drug delivery system may not be affected by the tear films, or this may not affect the tear films also. So it can protect from the mutual physical interaction if we are preferring the polymers with the pseudoplastic behavior. Now let us discuss on some of the main polymers what we utilized for development of drug delivery system. The major one is the hyaluronic acid. So they are again some biological polymer which is consisting of polysaccharides, and that is present in the eye, in the vitreous body at lower concentration. Now, along with this mucoadhesive properties, sodium hyaluronate is the main polymer, ophthalmic polymer, that is majorly used for development of drug delivery system. Why? Because of the water binding capacity, non-irritancy, increased viscosity, and the pseudoplastic behavior. So because of these properties, the first one is the water binding capacity. That means it can bound with the water molecules. It will not produce any irritation to the eye. it is having the higher viscosity, thus it retains for the longer period of time. Higher viscosity can provide higher muco adhesion. Higher viscosity can serve the loss of drug molecules. And the last one is the pseudoplastic behavior, which also reduces the interaction with the tear films. So these properties of the sodium hyaluronate make this sodium hyaluronate as a major or one of the main polymer for delivery of the ophthalmic drug delivery systems. The next polymer is carboxy methyl cellulose. So scientifically, carboxy methyl cellulose has proved that it can increases the concentration of timolol from 3 to 9 fold in the presence of sodium carboxy methyl cellulose. Again, which is compared with the non-viscous eye drops. So compared with the non-viscous eye drops, the delivery systems prepared using carboxy methyl cellulose. It is been tested with the drug timolol, which has proved that an increase in retention time, increase in ocular concentration of timolol from 3 to 9 times. This also improves the penetration of the drug molecule. The major reason for increasing this penetration is due to the longer retention of the drug in the cornea. Now, apart from this, a decreased rate of systemic absorption was also reported and attributed to the slower spreading of the solution onto the nasal mucosa. So you must listen to the sentence. Decreased rate of systemic absorption. That means the drug what we are administering, if you consider the normal tear drainage, what happens? The drug what we are administering into the cul-de-sac, it enters through the puncta into the nasal duct. From the nasal duct, it can enter into the systemic circulation. That means there are more chances for the entry of the drug what we are administering as an ocular route also, it can enter into the systemic circulation. But what happens if the drug in combination with carboxy methyl cellulose as a polymer, which reduces the systemic availability of the drug molecule? That means this is much favorable that this drug is not entering into the systemic circulation. In other way, the loss of the drug is very less. The drug what we are administering into the eye is only for providing what? Only for providing the local effect onto the eye. So administration of the drug by using carboxy methyl cellulose provides a longer retention and it reduces the loss of the drug molecules. The next one is the polyacrylic acid derivatives. This includes the carbopol as well as polycarbophyls. So both these polymers of acrylic acid differing in the extent of cross-linking and cross-linking agents. That means mainly all the polymers are being strengthened by the process of cross-linking. All the polymers immediately after coating or during the process of synthesis of the polymers, etc. And the last stage of this polymerization, we have a stage called the cross-linking. Cross-linking helps in increasing the strength and the rigidity of the polymers. Now, these polymers can differ in their extent of cross-linking and the types of cross-linking agents used. So, polyacrylic acids, they are pseudoplastic polymers which have with a very bioadhesive nature. Carbopol 934 is lightly cross-linked and having a higher molecular weight, and it is readily soluble in the aqueous solution. The precorneal retention of these polymers is greater than PVA, that is polyvinyl alcohol solution, as indicated by the meiotic response intensity of pilocarpine 1 hour after administration. So, the precorneal retention of these polyacrylic acid polymers in comparison with polyvinyl alcohol solution, because polyvinyl alcohol is another a normal polymer which is not that much of cross-linking or a retention time, polyvinyl alcohol. So compared with that of the polyvinyl alcohol, polyacrylic acid polymers which produce a significant effect as an ocular drug delivery system. This is being tested by the use of pilocarpine. So pilocarpine shows a higher retention time and with a less systemic availability as well as less loss of the drug while developed with the polyacrylic acid. The next polymer is the chitosan. Chitosan is also another naturally occurring biopolymer. It is obtained by alkaline deacylation of chitin, and it is utilized as one of the main vehicle for ophthalmic preparation as well as mucoadhesive drug delivery system, biodegradable drug delivery systems. So this chitosan exhibit various biological properties like the first one is biodegradation, non-toxicity and biocompatibility. That means it can be degraded biologically, that is within the system. If it is purely synthetic polymer which may not be degraded by our biological enzymes, whereas in the case of chitosan being a natural polymer which can easily be degraded by our enzyme. Moreover, this chitosan is non-toxic. It is not harmful, not producing any toxicity to our body, and it is highly compatible with our biological systems. It's not only with the eye, which is compatible with most of the tissues of our body. And chitosan shows a pseudoplastic as well as viscoelastic properties, and as a consequence it has coated a potential vehicle for instillation of the drug into the eye. So because of this pseudoplastic and the viscoelastic properties, this is being selected as one of the main polymer for delivery system. Now, formulation containing chitosan shows a high or prolonged residence by increasing the viscosity and by increasing the mucoadhesive property. So, same like other polymers also, chitosan also functions by increasing the viscosity and the mucoadhesive property. And this chitosan is highly active in neutral or slightly alkaline medium, that is especially in the case of tear medium the chitosan is highly active. Okay, so that's all for today. So I hope the session is clear for you. If you want a further clarification on the topics, the previous day's topic, that is use of penetration enhancers, you can listen to the previous videos. Okay, that's it for today. Thank you for listening.